So we're going to continue on with our rational numbers, and we're going to look at the operations of addition and subtraction today. So for our very first warm-up, I want to give you a little bit of time, so please press pause after the directions. But you're trying to look at finding the area of each of the pieces that are in this puzzle. So there is A, B, C, D, E, F, and G. So you need to find the area of each of those shapes. And so what we know is that the entire square has an area of 1. So there's no formulas required. You can cut it out if you did print it, or try and use a pencil to kind of see how the different pieces are related to each other. And I did give you a hint of how we're going to do this, and that is that A is equal to 1/4. So if you think about the whole puzzle that I have here for you, this section right here is 1/4. So think about why that is, and how that fits into what you know about fractions. So you should pause and try and figure that out. So what happens if you start to kind of break up this puzzle, you can see that if I cut D into 2 pieces, it looks like the same as our C. Well, it takes 2 C's. So if I start to cut up the other pieces, this triangle G down here can be those 2 pieces, and then even this F, which is actually called a trapezoid, or parallelogram, it has 2 triangles in it. So just looking at the number of these little triangles, there's 1, 2, 3, 4, 5, 6, 7, 8. Wait, did I miss 8? 8 of them. And so when I look at that, I'm like, oh, well, 8 of those make up half of this guy. So that means it would take 16 to make up the whole thing. So 16 of those pieces. So that means that one of these little triangles must be 1/16 of the whole thing. So that means that we have C is equal to 1/16. Well, we already know B is equal to 1/4 because it's the same as A. It's equal to it. And so then D is made up of 2 of those triangles, so that's 2/16, or you could say 1/8 if you think about simplifying. Part E is one of those triangles. Part F is made up of 2, so that'll be 1/8, and then part G is also 1/8. So how'd you do? Did you figure it out? So next we're going to add some fractions together, and I know that in your life you have seen fractions, but we want to think about it from a different perspective and really understand why it works the way it does, because our goal is to teach elementary school kids, and so we need to make sure we have that firm understanding. And often the concrete is how we need to get that across to our students. So if you have the algorithms memorized, that's awesome, but we want to know how to actually understand those algorithms. So I want to give you a little bit of time. Please try and draw pictures for part A and part B and see why the solutions are what they are. So I'm breaking up each of the fractions into fifths, because again we said that's the size of these guys. And we'll make a similar picture over here. And so we're going to take 2 of the fifths, and then we're going to add in, well, I could just do it from one picture. I guess I drew 2 for you, but we have 2/5 plus that's 1/5. So overall, that's taking up 3/5 of our circle. Then for the next one, we're looking at thirds this time. So we need to break this up into 3 equal pieces, or as equal as we can get. And again, let's draw, we have 1/3 going on, and then we're going to add to that 2/3, which really gives us just 1 whole. So we could say 3/3, but really that's 1 whole. Now another model that we could look at is using the number line to add. So if I break my number line in pieces, like saying, okay, here's 0, here's 1, and now I want fifths. So I need to draw 4 lines here, and these should be about equal size. And so I have 1/5, 2/5. And then we want to add to that another 1/5. So by the time we get to that one, we'll have 3/5 altogether. So again, this was 2/5, and we added the 1/5, so we get 3/5 altogether. And then similar for the 1/3, we'll go from 0 to 1, and then we're going to break these up into thirds. So we need 2 spaces there. So we go over 1/3, so we're at 1/3, but we want to add to that 2/3. So that's going to go over 2/3 and then go over to 3/3, which was our 1. So altogether, this will be equal to 1. So it's very similar to doing it with the area model or those pies, but we're looking at it with the number line. So next what we want to do is have our definition of adding irrational numbers. And so what you noticed, I think, are that our rational numbers, when they have the same denominators, so I'm looking at a over b and, wait a minute, oh no, this is supposed to be c over b, because our denominator is supposed to match. So you can see over here, it had the a over b and c over b. Sorry about that, little typo, sorry, typo. And so if the denominators are the same, that's telling us the size of the pieces. And so we have a of them plus c of them. And so altogether it's a plus c of them, and the size is still remaining the same. So now the next question will be, okay, so we get that, and that made sense for our last problems. But then when we have something like 3/4 plus 1/3, those ones have not like denominators. And so how are we going to approach that? Now, some of you guys might already know you need to find a common denominator, but let's look at the pictures to try and understand this. So I have 3/4. For some reason, I'm sticking with the pie, but you can use boxes if you'd like. So 3/4 is right there. And we want to add to that, make the same size whole or as close as I can, but this time it has thirds, so we have 1/3. So just looking at it, I can tell that I am going to be a little bit bigger than 1, because I can see that if I were to try and take that 1/3 and fill it in, it's going to be a little bit bigger than that space. And so when we're trying to add, it would be really nice if these were like the same size pieces. So we want to try and break them down into the same sizes. So when I look at the 3/4, I'm like, well, if I break each of these into 3 equal pieces, let's see, 3 equal pieces. Now, instead of having 3 of these pieces, each of those was broken into 3. So now I'm going to have 9. And each of the big 4 were also broken up into 3, so I have 12. So what I have pictured here is really 9/12. I'm going to do something similar to my 1/3, but let's break those into 4s. So let's see, half and then half again. It's the easiest way to make as equal pieces as I can. Well, kind of still. And so if each of these were broken up into 4, that's like multiplying that by 4 and then that by 4. You can see we have 4/12. So 3 of those 12s, 3 of those guys, will be able to fill in that space because they're the exact same size. They're 12ths of the same whole. So when we add those together, we're going to get 13/12, but really that's one whole and that little 1/12 left over. And so what we just did is we found common denominators, and the way that that common denominator happened was really just looking at, if I go back up, I'm going to kind of use this as my comparison, using the 4 and the 3 together to make 12. 4 times 3 is 12. That was going to be the common denominator. So anytime we have unlike denominators, we can rewrite really by multiplying by the kind of opposite guy, similar to the cross product we were looking at, but it's taking the fraction like a over b, multiplying it by d over d, and taking the fraction c over d, multiplying it by b over b, which those are still equivalent to each other. And so this is looking really, if we rewrite it a little bit, sorry about that, this will be AD over BD, and this is CB over BD also. And so now they have those same denominators. So if you look at the definition, that's exactly what they did. So if you look at the numerator, it's AD, which is what we had seen, AD, and then we saw the CB, and really it's just coming from multiplying by that opposite thing. And so just so you know, that BD is a common denominator, but it's not necessarily the least. And so we're going to see that in a little bit. about how we can find the least common denominator. Sometimes that's more helpful. So I'm going to give you a minute to try and work out parts A, B, and C. So make sure that you pause it and try. You don't have to use pictures for this, but you can use that definition from above. All right, now that you've tried them using that definition, all it says is that we're going to take the numerator times the denominator. Then we're going to take the other numerator times that other denominator towards the opposite. And we're going to be adding these together and then multiplying by that 2 times 3. So really this is 3 plus 2 over 6. So we're going to get 5, 6. So that's using the definition. Another way that you can write this is as those equivalent fractions with that denominator that matches. So to make this into 6, you multiply by 3. It's the same work, but maybe it's not as familiar using the definition. So we're going to multiply both of these by 2, and so we get 3 6 plus 2 6, which is still 5 6. So next we're looking at 4 twelfths plus 2 thirds. So we're going to do the 4 times the 3 plus, and we'll multiply 2 times the 12. And then this is all over the 12 times the 3. So we're going to have 12 plus 24 over 36. But that's just 36 over 36. And that's going to make one whole for us. Now, one thing that you might notice is that this reduced quite nicely, that 36 and 36. I mean, for one, it's 1, but also it just was able to simplify compared to the last one. And so some of you might have noticed that the LCM of 12 and 3 is not 36. The actual least common multiple is 12. And so I could actually rewrite each of these fractions as their equivalent fractions over 12. And so in order to do that, we would multiply the 2 thirds, top and bottom, by 4, which would make 8 twelfths. And then the 4 twelfths already stays the same. So then we'll end up with 12 over 12, which still does simplify, but you can see that the numbers were just a little bit smaller. So one of the advantages of using the least common multiple is that you'll end up with smaller numbers. Both of them are 100% right, just again, it works with smaller numbers, so there's a little less simplifying sometimes to do. So then for part C, this one, we can't find an LCM for x and y, so we're just going to use the definition. So we're going to have 5 times the y, so 5y, plus 3 times the x, and this will be all over the x times the y. And so this will be 5y plus 3x. Those are not like terms, so they can't combine, all over xy. That's our final answer. So one of the reasons for putting x's and y's into all of this, and that's kind of where this elementary school math is headed, is to algebra and variables. It's showing you that math doesn't have to be with such concrete examples. You can be a little bit more abstract. So you saw up above, like y and x. You don't know what those numbers are. You just know that they represent numbers, but you were still able to add some fractions together. So for the next couple problems, we're just looking at the fractions written a little bit differently. And so we have at the very bottom here, these are our mixed numbers. And that's when you have a whole and a part. And the ones up above, we already saw those at the beginning, but those are our improper fractions because the numerator is larger than the denominator. And so I know some of you guys know some tricks about like divide, and maybe when you look down here, like, oh, 5 times the 1 plus the 4, and it's like, okay, well, why does that work? And so when we look at the beginning problem here, 13 thirds, it said to draw the picture. So let's think about 13 thirds. So remember, 3 is our size and 13 is how many. So again, we know that this is improper because the top is bigger and we're going to be making some holes. So I'm going to need 13 thirds. So here's 1, 2, 3. We're going to have to make more. 4, 5, 6, 7, 8, 9. Pretend these are all equal thirds. 10, 11, 12, and then, oh, 13, finally reached it. So you can see that we made 4 holes out of the deal, and then we still had 1/3 over there, so that's going to be 1 out of 3. Which you also could have gotten by taking just the number 13 divided by 3. You know it goes 4 times, and that uses up 12 of those pieces really, and then we have a remainder of 1. And when we say that remainder of 1, it's this 1 out of 3 that we're talking about. So let's try that again. This time we're going to look at 5/2. So here we want our holes to be broken in to 2. Remember, that's our size. So we have 1 of them, 2 of them, 3 of them, 4 of them, and 5 of them, because that 5 was how many there are. And so all together we have 2, and then this last portion here, right, because it was all of that, so there's our 2 holes, and then we have 1/2. And again, that should seem familiar. I think some of you could do that in your head too, but we're taking 5 divided by 2, goes 2 whole times, which uses up 4 of the pieces, and we have 1 piece left, so that's why it's 2.5. For the second part, we're changing each of the following to an improper fraction. So really it's going like the other way. So we have 1 whole, and then we have 4/5. So if I break this up into fifths, I have 4 of them. 1, 2, 3, 4. And then over here I have a whole, but I want to break that up to see how many fifths are in there. So I'm going to make the split the same way. And so you can see I have 1, 2, 3, 4, 5, 6, 7, 8, 9. So for each whole, we know we're going to have 5. So there's 5 pieces there plus the 4/5. So we're going to have a total of 9 of these fifths. Which some of you might know that whatever the denominator is, you multiply it by 1 because it's 5 pieces in 1. And then you add the numerator together. So we can try that again here. We have 3 holes and then 5/6 of a whole. So let's see, let's break this up into 6 pieces. Trying to do equal pieces, pretend. And I have 5/6 of them. And I have all of those, all of those, all of those. So without actually drawing them, I know that I would have 6 pieces inside here, and 6 here, and 6 here, and 5 here. So then all together, this is really 3 of those 6s, so 3 times 6, and then we're going to add the 5, which makes me have 23. So there are 23 of these pieces, and they're 1/6. So that would be my final answer. And you can see right here that this matches up to what we would normally do, and some of you guys might have memorized, that you take 6 times the 3, and then you add the 5 in, which is exactly what we have written here. But now we have the picture to go with it. It's really the why, which is most important. Now this problem is from your book from page 294. So you can look at a word problem situation that is from a 6th grade book. And that situation has you basically working with these mixed numbers. So I'm going to look at step 1. And you can go ahead and read page 294, look at what that problem is, and then we're going to eventually solve the convince me. So pause it and read through these steps and try the convince me. So as you look through that, you could see that they found common denominators because they wanted to add the parts here. And so 2/3 was written as the 4/6 and 1/2 was written as 3/6. So in step 2 here, they have the 4/6, and you can see the picture of these little tiles here, which will all add together to make 7/6. And so then it says, okay, well you have 7/6, so then let's add the holes. Well, you know that there are 2 holes plus another hole, so that's 1. But then the 7/6, those line up, and 6 of those make another hole. And we have a little 1/6 guy left. So altogether, there's actually going to be 3 holes, and then 1 and 1/6, which gets you that 4 and 1/6. So So you can see this one is going back to using those fraction tiles that we saw in the previous lesson. It's really nice so students can see how they have that improper fraction going on and that they were able to rewrite it. Okay, so the next one we want to look at is the convince me. So you're supposed to try this. Let's see, Kyle used 9 as an estimate for 3 1/6 plus 5 7/8. So 3 1/6, so remember those benchmark fractions we were talking about being between 0 and 1, well, closer to 0, closer to a half, or closer to 1. So when you're looking at 1/6, 1/6 is like so small, so I'm going to estimate that to be about 3. And then 5 7/8, 7/8 is a lot of the whole, so that's going to round up to 6. So you can see where his 9 was coming from as his estimate. And so that seems very reasonable when we see that he got exactly 9 1/24, because 1/24 is so small. Now, we can kind of verify it by actually doing it, but it wanted us just to explain if his answer seemed reasonable, and the answer to that is yes. To have 9 and get an exact sum of 9/4, it seems reasonable. And it's always a good idea, especially with fractions, to try and estimate your sums first, or even after, just to see if your answer makes sense. So let's actually add these together. Let's see what happens. So I have 3 1/6 plus, I'll line it up like they did right up above, 7/8. And so we could rewrite this with a common denominator. So 6 and 8, the LCM of 6 and 8 is going to be 24. You could verify that. So I need to multiply this fraction. Let's see, top and bottom we'll need 4, so that's going to be 4 24. And on the bottom we're going to need 3, so 3 over 3. So we're going to have 21 over 24, and we have 5 here. So altogether we're going to get 8 25 24. But when you look at that 25 24, you can see that we have made one whole. So we have 8 plus 1 whole, and then 1 guy left over, which 9 1/24. Yay, Kyle did a good job, and you did too. You got that, 9 1 over 24. Okay, so we talked about addition being the combining and adding together. Now we're looking at subtraction, which was, there's a few different ways to look at it. We're looking at that takeaway model for subtraction. And so if we start, we're looking at these fractions right here, 3/5 minus 1/5. I want to give you a little bit of time to try these first. So pause it and then come back. So let's see, 3/5. I don't know why I went with fifths on all of these. Hardest thing to draw. Let's see here. Those are about equal. And so what we have here is 3 of these fifths, and we want to take away 1 of the fifths. So we're going to take this guy out. And so then all that we're going to have left, try and make it so you can see, all we're going to have left will be just those 2 little pieces. So if we started with 3/5 and we took away 1/5, our final answer, this will be equal to 2/5. Now, I said to estimate to see if your answers seem reasonable. So if we are going to estimate that, just kind of check. 3/5 is kind of close to a half, and then 1/5 is close to 0. So if you're going to subtract those, you're going to get something close to a half, which 2/5 is, like we talked about last time. 2.5 over 5 would be exactly halfway, so it's pretty close. So my answer seems reasonable. Now next we're looking at 5/8. So we're back to the 8s. Those ones are kind of nice. Let's put that up as evenly as I can. And so we have 5 of those guys. There's 1, 2, 3, 4, 5 8s. Now we need to take away 1/4. So that's not as easy because it's not the same size. We have that size 4. So on this time I'm going to use my circle to make sure I know what 1/4 exactly looks like. So 1/4 is this guy. And so when I'm looking over here, that's really like this guy here. And so I know that 1/4, just looking at the pictures, is actually equal to 2/8. And again, that makes sense with the equivalent fractions. So I'm going to say I want to take that part out. So like we did a second ago, this part is going to go away. So really I'm looking at 5/8 minus 2/8. And then you can see I have 1, 2, 3 of those 8s left over. And just kind of seeing if this makes sense with like some estimation. 5/8 right there. 5/8 is close to a half. 1/4 is like right in the middle. So if you're rounding, 5/8 is rounding kind of down, and then 1/4, if I round that to like 0, so rounding both of those down, I get 1/2. And so when you look at our fraction 3/8, that's pretty close to a half. So not bad estimate. Now for the last two, I did the estimates, but maybe you didn't think that that was entirely necessary because they weren't that hard of problems. But when I look at these problems, starting with part C, I really like to see with the mixed numbers what an estimate would be. So it's like you have 5 and a little bit minus 2 and a little bit bigger bit. So you know that the estimate would be about 3. But it's actually going to be less than 3 because the part right here, 2/3, was bigger. So we'll see. So it's about 3, but just keeping in mind that it will be less. So if I draw the picture of the situation here, we have 5 of the wholes. 4, 5, trying to make them all equal. And then we have 1/3 of a whole. So we have all of this, 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 and then we have 1/3. And so we need to take away this guy, he's gone. We're going to take away this guy, he's gone. So those are my 2 wholes. And now I need to take away the 2/3. But I only have 1/3 to take away. So that means one of my wholes, so out of the 5, one of my wholes is going to have to be broken up into thirds. So you can see right now I have 4/3 hanging out. And so this should sound kind of familiar to taking like a 10 and breaking it into ones, or taking our base 5 long and turning it into units. So now we have 4/3 and we can take the 2/3 away. It leaves us with 2/3. So to show you that takeaway, we're going to take that away, and then you can see the 2/3 and 2 that's left over. So what I have is 5 and 1/3 minus 2 and 2/3. Even though they are the same size pieces, this one is taking more away than I have. So we are basically borrowing from that 5 and adding that 3/3 there. So it looks like 4 and 4/3 minus 2 and 2/3, which will become the 2 and 2/3 that we got. Again, the visual is really nice to help us understand how we needed to do kind of that borrow, which we might have said. All right, so let's look at part D. So we'll start with what we have before we try and take anything away. It says 3 1/2. So I'm going to draw that in here. So 3 wholes and 1/2. And so we want to take away 2 wholes. So that's easy. Take that away, and then we need to take away 2/3. Well, 2/3 is bigger than 1/2 because 2/3 is taking our whole into 3 spots, and you can see visually that that's more than 1/2. So I need to somehow realize how much 1/2 really is. So you can think about the common denominator. We can also think about all of our halves, breaking them up into 3 equal pieces. And if we have thirds going on, kind of breaking those up into 2 equal pieces. And so you can see right now we have a total of 1, 2, 3, 4, 5, 6 of those 6, because we took thirds and broke them up, or thirds and broke them up in half. and we took our half and broke it up into thirds, so we still had 6 pieces. That's 3/6. So all together now we have 9/6. And so we want to be able to take away 2/3 from that. Well, 2/3 is really 2/3, if you break this up into 6, that's 4 of those 6. So we're going to take away, how many did we say? 4, 6. So we're going to take away one of these guys gone, 2, 3. So those guys gone, and one more of those gone. And so you can see we have 5 of those guys left. So 9 of the 6 minus 4 of the 6 ends up that we have 5, 6 left over and no holes. So that would be my final answer. If you want to see that worked out vertically like we did on the last one, that's 3 1/2 minus 2 2/3. So we rewrote the fractions as equivalent fractions, so 3 3/6 by multiplying by 3/3, and minus 2 4/6, and that's multiplying by 2/2, the whole opposite thing. And so we take 3/6 minus 4/6, we can't again, so we'll have to take one of our wholes and split it up, which is what we did, into 6, 6. So altogether with 9, 6 hanging out there, minus 4, 6, that's 5, 6, and 2 minus 2, those are all gone. So we get the same answer. Now, you could have also changed these into improper fractions. So we could have written this as 2 times 3 plus 1, 7/2 minus, that's 6 plus 2, 8/3, and you should get the same answer. So leave that up to you to check, but it should be 5/6. All right. For these last 3, it was really just estimating. And so to estimate, we're going to use benchmark fractions, or you could do some other kind of like clustering or grouping too of things that look kind of familiar. So first off, when I see 23/10, I see the top is bigger than the bottom, and it's almost twice as big. So that's going to be about 2. And 10/9, that's just a little more than 9 out of 9, so it's just a little more than 1. So my estimate would be about 3. When I look at part B, I notice 9/10, that's really close to 1. And so right here, I'll have 4 holes. Same thing with 7/8, that's really close to 1. It's an eighth away, so that would turn into 3. And 11/12 is a 12th away, even closer, so that's going to be about 1. So my estimate would be 4 plus 3 plus 1, which is really equal to 8. And then the last one here, I have 7/8, which is close to a whole. I have a half, which is exactly a half here. 2/5 is really close to a half also. And then 1/16 is close to 0. So if I try and group kind of like these two guys together first, I have like 11.5 plus 2.5. Well, that's going to be 13 plus the 1, so that's going to be about 14. And then I'm going to add the 1 and 3 together here, that's adding 4. And then the 5 and the 0, that's adding 5. So it looks like all together we're going to get, this is going to be about 23 for my estimate. Now you can go back through these last 3 and find the exact values by finding a common denominator, and then double check that your estimates or that your answers are reasonable. Because we have these estimates, which our exact values should be close to. Otherwise, we did something wrong with those exact values. And that's it for today. We're going to move on to multiplying and dividing next.